All right, let's graph number 4. So intercepts, y-intercept, plug in 0. All right, we plug in 0, we're going to get 1 over 0. That's undefined. So there is no y-intercept, undefined. So there is no y-intercept. X-intercepts. When is the numerator equal to 0? Numerator is 1 or -1, doesn't matter. It's never equal to 0. So no x-intercepts. All right, asymptotes. What do we got? So horizontal asymptotes. So we have the degree of your denominator as 1, the degree of your numerator as 0. Again, x to the 0 power is 1. So the degree of your denominator is larger. When that is the case, the horizontal asymptote is at the line y equal to 0. So when you plug in very large numbers, this one, for example, we would have -1 divided by 2 times very large numbers, or very small, and that will go closer and closer to 0. So 1 divided by 2 trillion, it's going to be very small, 2 point, or 0.00000 and so forth. Or negative, and it just switches the sign on you. All right, so that is kind of why that happens there. Vertical asymptote. Take your denominator, set it equal to 0. So it occurs when x is 0, so that line is the vertical asymptote. So y equal to 0 is there, your horizontal asymptote. X equal to 0 is there, your vertical asymptote. And then other than that, there's no intercepts. I mean, we can make a table just to get some values. So let's plug in 1 and -1. I plug in 1, you get -1/2. Plug in -1, you get +1/2. So 1 and -1/2, -1, +1/2. And you can pick more points, fill it in. It's going to approach the vertical asymptote in that direction. Then the other branch goes this way. If you were to relate it to 1 over x, a parent function, that one looks like this. So then this negative flips it. So it flips it, putting the branches in the other quadrants. And then this 2 is going to actually be a horizontal dilation by a factor of 1/2. But it's kind of hard to see it when you do it by hand. I would graph it in the calculator to compare -1 over x and -1 over 2x. In any case, here's the graph. Those are your asymptotes, no intercepts. Let's go to number 5. All right, same process. Intercepts and asymptotes. Suppose that they exist, but again, we're not going to have any in this section, I believe. Y-intercept. Plug in 0. You get 2 over 1. That's 0, so 2 over 1. 1, 2. X-intercept. Set it equal to 0. After step 1, you just have your numerator. That's never equal to 0, so there are no x-intercepts. Asymptotes. Horizontal asymptote. Let's see. Degree of your denominator is 2. Degree of your numerator is 0. Degree of your denominator is larger. Horizontal asymptote at the line y equal to 0, the x-axis. So we got that there. Vertical asymptotes. So let's set my denominator equal to 0 and get to solving. Square root. So x is equal to plus and minus square root of -1, which is I. So that's an imaginary number. It's not a value on our current xy plane, which only deals with real numbers. So because of that, there are no asymptotes. An imaginary number. There's nothing we can do with that. At this point anyway. All right, so let's kind of see what's going on. Is this going to cross my horizontal asymptote? Well, set it equal to it. See if we can find an x value such that the output's 0. As you start solving, you'll find out it never happens. There's no x value to give you 0 for an output, so it'll never cross the horizontal asymptote. Let's plug in some numbers in, just to kind of get an idea of what's going on. Something's happening here, so let's plug in numbers around it. It's really your choice. Plug in 1, get 1 square 1. You get 1 here. Plug in -1, you also get 1. We're going to have some symmetry here. This is going to be an even function. Whether you plug in a negative or positive value, you're going to get the same result. Plug in 10, 10 squared is 100, so we get 2 over 101. Negative 10 squared is also 100, so you get the same result. So it gets closer and closer to 0. So it's going to be symmetric. It'll approach the horizontal asymptote. It peaks there. In calculus, you'll take the derivative and verify that that's a maximum. And the graph looks something like that. No vertical asymptotes, a horizontal asymptote, a y-intercept, no x-intercept. This one's actually continuous. There's no breaks in it. That one's done. This one, our domain would be all reals. Your range would be 0, parentheses, 2, square bracket. This one doesn't have any gaps. This one's a little different than the previous ones we have seen. On the other ones, the domain, we had to throw out the x values that gave us our vertical asymptotes. Let's throw out the values that made your denominator 0. Alrighty, last example. Here we go. Intercepts. So y-intercept. Plug in 0. So 0, 0, 0, 0 over 12. So there's our y-intercept. X-intercept. Set your numerator to 0 and solve. So it's the same point as the y-intercept. So this was crossing the origin. Asymptotes. Horizontal asymptotes. Let's see, degree of your denominator is bigger than the degree of your numerator. So y equal to 0. And you can see this graph is going to actually cross the horizontal asymptote at 0, 0. All right, vertical asymptotes. It requires a little more work. Take your denominator, set it equal to 0, and solve for x. It's quadratic, factor if you can. If not, quadratic formula or completing the square. Positive times a negative to get that minus 12. Negative 6x plus 2x to get that negative 4x here. So at the line x equal to -2 and x equal to 6, we have a vertical asymptote. So this one has 2 of them. So let's put those there. 1, 2, 3, 4, 5, 6. 1, 2, -2. All right. So we broke this down into 2 factors. X minus 2, x plus 6. I'm sorry, plus 2 minus 6. There we go. Just double check the word. Yeah. Okay, let's finish this off. We need a table of some sort to help guide us, see what's happening right around these values. So I'm going to pick, let's go -3, -2 we cannot plug in. Let's plug in -1. Let's plug in 5 and 7. So I'm just picking numbers right around our vertical asymptotes to see what's going on. All right, I plugged in some values. I calculated them off to the side. So -3, -2/3, we're here somewhere. -1, +2/7 here somewhere. Got that point there. +5, -10/7 down here somewhere. 7, 14/9 up here somewhere. Okay, you can make more and more points as you wish. This one is going to approach the vertical asymptote in that direction. This one here, they're going in opposite directions. The multiplicity of these factors over here were odd. So the graph will approach the asymptotes in opposite directions. Plug in more points, you'll see that it gets closer and closer to 0 till it crosses, and then it'll shoot up this way. This one will go in the opposite direction, and then get infinitely closer to the asymptote. The graph looks something like that. Get more points for more accuracy. And again, if you wanted to check to see if and when it crosses the horizontal asymptote, you would set it equal to that. And when you solve this, you find out it's equal to 0 and x is 0, which was the intercept. And it only happens once. It's only going to cross it once right there. So at the other parts of the graph, it'll just get closer and closer and never crossing it. And again, plug in more values if you wish to get more points. All right, that is all the examples for D13. If you have any questions, always shoot out an email or message me on our Google Class or whatnot. All right.